Hey everyone, and welcome back. Today we're going to be taking a deep dive into some really fascinating research about large language models.
LLMs,
Yeah,
to
LLMs.
be short.
Exactly. And specifically, how to tell when they're basically just making stuff up.
Mm-hmm.
Like those AI systems that can write poems and answer your questions, even write code.
Mm-hmm.
They're everywhere these days.
They're not perfect.
Yeah, they're definitely not perfect. And what's really wild is this research actually found a link between how fast an LLM responds
Uh-huh.
and the length of its answer.
That's right. And this has some pretty big implications, especially as LLMs are being used more and more for things like question answering chatbots.
Oh, yeah, for sure. Like
Yeah.
the ones you see in healthcare or IT support.
Exactly, where accuracy is critical.
Absolutely. So before we get into all that, can you just give us a quick refresher on what exactly LLMs are
Sure.
and why they sometimes hallucinate?
Yeah, so basically, you can think of an LLM as this program that's been trained on a massive data set of text and code. And it learns to predict what words or code should come next based on what it's already read. It's kind of like a supercharged autocomplete.
Oh, I see.
But instead of just finishing a sentence, it can write entire paragraphs or even programs.
Wow.
The problem is that sometimes these predictions, while they might be grammatically correct and sound plausible,
Right.
are actually factually wrong
Uh-huh.
or completely nonsensical.
So it can sound really convincing even when it's making stuff up.
Exactly. That's what we call a hallucination.
Okay, so why does that happen?
Hmm.
Why would it just make stuff up?
Well, one reason is that the prompt, the input you give to the LLM, like a question you ask it,
Yeah.
might not actually provide enough context.
Mm.
You see, LLMs, they work with probabilities, not absolute truths.
Okay.
So they estimate the likelihood of different words based on the patterns they've learned from the data.
Uh-huh.
But if the data is incomplete or biased, or if the prompt is ambiguous, it can lead to errors.
So it's not really its fault in a way.
But it's the limitations of the technology.
Right. So how do we catch these errors before they cause problems?
There are a few different approaches.
Yeah.
One is to analyze the probability of each word that the LLM generates.
Okay.
If a word has a very low probability in the context of the generated text, that could be a red flag.
Mm.
Then there's also fact-checking, which involves comparing the LLM's output to external reliable sources.
Right. But I imagine those both have limitations.
They do. The probability approach can get very complex, and fact-checking can be really challenging to implement on a large scale.
Yeah, especially if you need to constantly update your sources.
Exactly.
So this research focused on a different approach called consistency-based hallucination detection.
Right.
What is that?
So it's basically based on the idea that if you ask an LLM the same question multiple times and it gives you consistent answers,
Okay.
it's less likely to be hallucinating. It's like if you're getting a second opinion from a doctor.
Mm-hmm.
If they both give you the same diagnosis, you're more likely to trust it, right?
Right. Okay. So how does that actually work in practice?
So the researchers tested two main methods. The first one is quite simple. You generate 5 different answers to the same question,
Okay.
and you see how similar they are. If they're all pretty much the same, that's a good sign.
Makes sense. The second method sounds a bit more complex.
Yeah. It involves generating multiple variations of the original question, comparing those for similarity,
Uh-huh.
and then generating and comparing answers for each variation.
Why go through all that extra effort?
Well, the idea is that by subtly rephrasing the question, you're kind of testing the LLM's understanding of the underlying concept from different angles.
I see.
If it can consistently generate accurate answers, even when the wording of the question changes, that's a much stronger indication that it truly understands what's being asked.
So it's not just memorizing phrases or something.
Exactly.
Now, I remember you mentioned something called a consistency determining threshold.
Yes.
What exactly is that?
So that's a key element of both these methods.
Oh.
It's basically a cutoff point that determines how much variation is allowed between the answers, or
Yeah.
question-answer pairs before the system flags a potential hallucination.
So if the variation is too high?
Right. Then it suggests that the LLM might be making things up.
We'll definitely have to get into the implications of this threshold later on.
Definitely. It plays a big role in how sensitive these methods are to potential hallucinations.
For sure. So we have these two techniques for detecting hallucinations. How did the researchers actually test them out in a real-world setting?
So they used 2 real-world data sets. One involved healthcare with questions and answers about various medical conditions,
Okay.
and the other focused on an enterprise IT help desk, the kind you might encounter if you had a computer problem at work.
Oh, yeah.
They fed these questions and answers to an LLM and then used these methods to see how well they could identify potential hallucinations.
Got it. And what did they find?
Well, one of the most interesting discoveries was that the response time of the chatbot, the LLM, actually varies depending on the length of the answer it generates.
Wait, so longer answers mean longer wait times.
Yeah.
Isn't that just common sense, though?
It might seem that way, but remember those more complex techniques we talked about?
The ones that generate multiple answers and rephrase the question?
Exactly. Those are much more computationally intensive.
Oh, right.
They require the LLM to process more information and make more calculations. And the longer the question answer are, the more data the LLM has to work with.
Uh-huh.
And that can take more time.
So it's not just about the time it takes to, spit out the words.
Right.
It's about the time it takes for the LM to actually analyze all that information.
And generate a response that passes that consistency check.
Wow. That's really interesting.
It is.
Yeah.
It highlights the complexity of these systems. There's a lot going on behind the scenes, even when it seems like the LLM is just responding instantly.
And I bet this has some serious implications for how we actually use LLMs in the real world,
Yeah,
especially in those time-sensitive situations you mentioned earlier, like in healthcare.
for sure.
So what else did the researchers discover?
Well, they also looked at the precision of these techniques, how accurate they were in identifying true hallucinations without too many false positives.
Okay.
And what they found was that the precision varied a lot depending on the data set.
Okay, so you're saying the techniques work differently for healthcare versus IT.
Exactly. And in the next part of our deep dive, we'll explore why that might be and what it means for using LLMs in different fields. We'll also talk about the implications of those consistency thresholds
Okay.
and how they can affect the balance between speed and accuracy.
Awesome. I'm excited to hear more. So we just left off talking about how the precision of these techniques varied between healthcare and IT questions.
Right. Even though the techniques themselves were the same, the results they got were different depending on the subject matter.
Hmm. It's like context really matters for these LLMs.
It really does.
So what exactly caused that difference? Were the techniques just better at medical questions?
Well, it's not quite as simple as that. One explanation that the research suggests is that the LLM might have been trained on way more medical information.
Oh,
So it would be more familiar with all the medical terminology and all the concepts and less likely to hallucinate in that area.
so it's like an LLM that's like a medical expert,
Right.
but maybe not so much when it comes to IT.
Exactly.
But if that's the case, couldn't you just train it on more IT info and then it would work better?
Yeah, that's definitely the hope. But the research also suggests another more subtle possibility.
Okay, what's that?
So the LLM might have been overconfident in its IT knowledge,
Oh,
and because of that, it actually ignored important context from the enterprise data set and generated more hallucinations.
wow. So it was like too confident for its own good.
Kinda, yeah. And that actually brings us back to those consistency thresholds that we talked about before.
Right. So how do those thresholds play into all of this?
Well, the researchers found that if you adjust that threshold, it actually has a really big impact on how many hallucinations get flagged. Remember, a higher threshold means more trust in the LLM's initial answer,
Uh-huh.
and a lower one means that more answers get flagged as potential hallucinations.
Yeah, it's like a trade-off.
Yeah, it is. It's a balancing act.
So could this be the key to solving that speed versus accuracy problem we were talking about earlier?
It's possible. You could imagine a system where the user could actually adjust the threshold themselves depending on what they need.
Oh, that's interesting.
Yeah, so like in a situation where speed is super important, like a medical emergency, you might accept a higher threshold even if it means you might miss a few hallucinations.
But for something like legal research.
Right, where accuracy is non-negotiable, you might want a lower threshold even if it means you have to wait a bit longer.
So basically give users more control.
Exactly. And that could lead to like a more tailored and efficient way to use these LLMs.
That makes a lot of sense. What are some other ideas for addressing this speed versus accuracy issue?
Well, the researchers are also looking into these hybrid systems.
What are those?
So they would combine the speed of the simpler techniques with the precision of the more complex ones.
Oh, okay.
So maybe you could have a quick initial check with a simple consistency method to flag the most obvious hallucinations.
Okay.
And then for the answers that pass that check, you could do a more in-depth analysis if you need to.
Got it. So it's like a two-step verification process.
Right.
I really like that. This is getting me excited about the future of LLMs.
Me too. There's a lot of promising research happening. Another exciting area is developing new LLM architectures that are just inherently less prone to hallucinations.
Oh, wow.
Yeah.
So not just improving the detection methods, but actually fixing the problem at its source.
Exactly. And that involves a lot of things like Refining the training process, making sure we're using really high-quality data, and finding ways to make the LLM more sensitive to context and less likely to overestimate its own knowledge.
That makes sense.
Yeah.
So basically trying to prevent hallucinations from happening in the first place.
Right, and that's where things get really interesting, because as we understand these models better, we can come up with new techniques to make them more reliable, more transparent, and ultimately more useful in a wider range of applications.
Okay, but let's take a step back for a minute. We've talked about healthcare and IT, but what about other areas where LLMs are becoming more common, like content creation, marketing, even scientific research?
Yeah.
Do these findings have implications for those fields too?
Absolutely. LLMs are already being used in all of those areas, and the potential for hallucinations is definitely a real concern.
Yeah, I could see that.
Like, imagine a marketing campaign that uses an LLM to come up with catchy slogans.
Uh-huh.
What if those slogans are actually misleading or just plain wrong?
Right. Or what if you're using it to write a scientific paper and it hallucinates data?
Yeah, that could be really bad.
So even though these systems are really powerful and have a lot of potential, we can't just blindly trust them.
Exactly. We need to be aware of their limitations.
Right. And that's why research like this is so important.
Definitely. It helps us uncover those limitations and figure out how to address them.
Okay, so what's the takeaway for our listeners? What should they be doing?
Well, the first step is just being aware that LLMs, while powerful, are not perfect.
Got it. Don't just believe everything they say.
Right. Question their outputs, especially when you're dealing with important information.
It's like with any new technology, we need to approach it with a healthy dose of skepticism.
Absolutely. And we need to stay informed. This field is constantly evolving.
Yeah, the research is moving so fast.
It is. So by staying up to date on the latest findings and developments, you can make better decisions about how to use these tools in a way that's both effective and ethical.
So be proactive.
Exactly.
Don't wait for problems to come up. Try to anticipate them and think critically about how LLMs could be used or misused.
And that leads us to the final and probably most important step, which is engagement.
Okay.
We need to have open and honest conversations about what LLMs mean for society.
Like about ethics and bias and how they might impact different groups of people.
Exactly. These are tough questions with no easy answers. But by talking about them and sharing our knowledge and perspectives, we can work together to shape the future of LLMs.
To make sure they're used for good.
Right.
That's a really powerful message. I think our listeners are getting the picture. Blind trust in LLMs is not the way to go.
Right.
We need to be aware of what they can do, but also their limitations.
I agree. And in the final part of our deep dive, we'll talk about what all of this means for you, our listeners,
Okay.
and what you can do to navigate this crazy world of LLMs.
Okay, so welcome back, everyone. I feel like we've covered so much ground already in this deep dive into LLMs.
Yeah,
You know, those AI systems that can do all sorts of things like write and answer questions, even generate code.
And we've been focusing on this really interesting problem of them hallucinating.
Right. Like when they give you information that sounds super convincing, but it's actually completely wrong.
Yeah. And we talked about how the length of the LLM's answer can actually affect how long it takes to respond.
Especially when you're using those more complex techniques to double check for consistency.
Exactly. Because those techniques require a lot more processing power. You know, like generating multiple answers and then comparing them.
Yeah, it's not just about spitting out the first thing that comes to mind.
Right. There's actually a lot of work going on behind the scenes. And that brings us to this really important trade-off between speed and accuracy.
Right, because sometimes you need an answer quickly, even if it's not perfect.
Yeah, like in a medical emergency, for example.
Exactly. But then other times you need to be absolutely sure that the information is correct.
Right, like if you're doing legal research or scientific research.
So it's kind of like choosing how you want to travel. Sometimes you need the speed of a taxi, even if it costs more.
Uh-huh.
But other times you might prefer to take the scenic route on a train, even if it takes longer.
I like that analogy. It's all about what's most important in that specific situation.
Exactly. So knowing that these LLMs aren't perfect, what can our listeners do to make sure they're using these tools responsibly?
Well, I think the first step is just being aware that LLMs are powerful, but they do have limitations.
Right. Don't just blindly trust everything they tell you.
Yeah, it's important to question their outputs, especially when you're dealing with important information.
Like double check things.
Exactly.
And I guess it's kind of like with any new technology, you know? You got to approach it with a little bit of skepticism and be willing to learn as you go.
Definitely.
Hmm.
And another important thing is to stay informed about the latest research.
Because things are changing so quickly.
They really are.
Mhm.
New discoveries are happening all the time. So by keeping up with the latest findings, you can make better choices about how to use these tools effectively.
So be proactive, not reactive.
Exactly.
Don't wait for problems to happen. Try to anticipate them.
And think critically about how LLMs could be used both for good and for bad.
Right, because they're just tools.
Hmm.
And it's up to us to use them responsibly.
And that leads us to the final and I think most important point, which is engagement.
Okay, what do you mean by that?
I mean, we need to be having open and honest conversations about the implications of these LLMs.
About the ethical considerations.
Yeah, about potential biases, about how they might impact different groups of people.
These are big questions.
They are. And they don't have easy answers. But by talking about them and sharing our knowledge and perspectives, I think we can work together to make sure that LLMs are used in a way that benefits everyone.
So it's not just about the technology itself.
Right.
It's about the human element, too.
Absolutely.
That's a really great point.
Mm.
I think our listeners are starting to get the message here. We need to be careful with LLMs and not just assume they're always right.
Exactly.
Well, this has been a fascinating conversation. I feel like I've learned so much.
Me too. It's been great talking to you.
And thanks to all of our listeners for joining us on this deep dive into the world of LLMs. Remember, they're powerful tools with a ton of potential. But it's up to all of us to use them responsibly and ethically.
Couldn't have said it better myself. Thanks for listening, everyone.